Hi everyone, we are moving on to a new lesson. We are in Module 3. We're still in Topic 1, but we're moving on to Lesson 3. I don't know why this is so blurry. I've been trying to get it to not be, but okay. We are on page 371. Our key term is the word called like terms. There we go. And our learning goals with equivalent expressions. To model algebraic expressions with something called algebra tiles. Rewrite algebraic expressions using algebra tiles. Rewrite them using the associative, commutative, and distributive properties. Apply properties of operations to create equivalent expressions. And rewrite expressions as the product of two factors. Okay, so let's get started here. So it says evaluate each expression. So we have 5 divided by 3/4. So remember the 5 is really over a 1, and instead of dividing by a fraction, we are going to multiply by its reciprocal. So remember, you keep it, you change it, and you flip it. And then we multiply straight across, so we get 20/3. It's okay to leave it like that. If you wanted to change it to a mixed number, we can get 6 whole groups of 3 out of 20. 6 times 3 is 18. There would be 2 out of 3 left, so 6 2/3. Okay, number 2. 24 hundredths divided by 6/10. So let's set this up as a division problem. 24 hundredths divided by 6/10. And you guys should be able to see this as 24 divided by 6. So I know that you know the answer is going to be somewhere around 4, but where's your decimal point going? So let's take a look here. So it is in tenths here in our divisor. So if we multiply by 10, it moves it here, and then we have just a whole number. We have to multiply by 10 here, it would move it over, and then up here. So then it would really look like 6 into 2.4 with a decimal point going up there. How many groups of 6 can you get out of 24? And that's 4. So 4/10, because then we do get 0. And it makes sense here because 6/10 times 4/10, tenths times tenths gives you hundredths, which is what we had started with here. So 4/10, 6 2/3 or 20/3 is your answer there. Okay, 3 and 4. 14 plus 8 divided by 2 or over 2. So 14 plus 8 is 22 over 2, which equals 11. 14 halves plus 8 halves. So when we're adding fractions, we need to have common denominators, which we do. So the denominator stays the same, and then we just add the numerators. So we're adding 14 and 8, and we get 22, which equals 11. So question 5 here then says, what do you notice about the answers to questions 3 and 4? And obviously they are the same. Okay, and that concept is going to come back into play here in a little bit. For now, let's flip the page. We're going to go over to the getting started. So we're on page 372. The Johnson brothers collect sports gear from their favorite teams. Jaden has a number of jerseys and a number of caps. They're not telling us how many, he just has some amount. Jerome has twice as many jerseys as Jaden, but he has the same number of caps. Josh has 3 times as many jerseys and caps as Jaden. Jack has 4 times as many caps as Jaden, but no jerseys. Okay, then in number 1 it says, your teachers provided you with algebra tiles, which I will do that in class. If you're doing this from home, you can just write letters, X and Y's, to represent this. If you have maybe a handful of coins, you could do that. Maybe pennies could be your X, dimes could be your Y, because we're going to use these little squares. Our X is going to be yellow, our Y will be red.
So you could draw different colored squares. You could just write X's or Y's. You can do whatever you need to. If you have M&Ms or, I don't know, the marshmallows out of Lucky Charms or something. Someone let me know if you're listening to this part of the video, hearing these crazy things I'm suggesting. Okay, so let's show how many Jaden has. So Jaden has a number of jerseys and a number of caps. So we don't know exactly how many. It says the X tiles represent the number of jerseys. So we'll say he has that many jerseys, and the Y tile represents the number of caps. So this is the number of caps that he has. So we're going to label it so that we know what we're doing here. So jersey caps. This is our Y, this is our X. So he has some number. So that's the amount he has. I don't know how many that is. It's just some amount. Pretend that there's like a mystery number written on these. Okay, so Jerome has twice as many jerseys as Jaden, but the same number of caps. So if Jaden has one of these jerseys and Jerome has twice as many, how many yellow algebra tiles will I put there? All right, I'll put 2. So he'll have 2 of those. And it says, but the same number of caps. So I'm just going to put 1 of those. Okay, so how about Josh? Josh has 3 times as many jerseys and caps. So 3 times as many jerseys as Jaden. So he'll have 1, 2, 3 of them. 3 times as many, and of the caps too. So just to point this out here, let's say he had 2 jerseys. Then every one of these would represent 2. So Josh would have 2, 4, 6. Jerome would have 2, 4. Twice as many as 2 is 4. 3 times as many as 2 is 6, and so on. Jack has 4 times as many caps as Jaden, but no jerseys. So he doesn't need any jerseys at all. We just need to give him some caps. And how many? 4 times as many. So here he is, 4 times as many caps. And then it says, use the algebra tiles to model the total amount of jerseys and caps the Johnson brothers have, and sketch the models you create. So let's just kind of go back here for a second. This is kind of our key in it. So we know Jaden has an X and a Y. So I'm going to take his and kind of draw it down here. So Jaden has 1 X, 1 Y. Let's do Jerome next. Jerome has 2 X's and 1 Y. Josh has 3 X's and 3 Y's. Jack has 4 Y's. So how many do they have all together then? So let's kind of figure that out. Oh my goodness, you couldn't see that at all. I'm so sorry. I'll pause for a moment. Okay, hopefully you got that. So then together, I'm just going to kind of draw a line here. Together, what do they have? So there's 1, 2, 3, 4, 5, 6 of the X's. And how many Y's? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of the Y's. 3, 4, 5, 6, 7, 8, 9. Okay, so write an algebraic expression to represent it. Well, okay, so we have 6 of the yellows, right? I could really go like this. We have 6 of the yellows, and we have 9, and as plus 9 of the Y's. We have 6 yellow, 9 of the red, which is 6 of the X's, and 9 of the Y's. So 6 jerseys and 9 caps between all of them.